So I'm going to just compile it here and then run it off of the console. So right now, it's taking the argument 0, 1, or 2, which correspond to the difficulty easy, medium, or hard. So I'm going to do easy, and at the moment, it's just going to do the breadth first search. So in the console, you can see printed out, it says the difficulty and the algorithm that it used. And then it basically prints the states that the board goes through, all the moves that it makes, and it says which direction the blank moved as well until you get the goal state, and it says how many moves it took to get there. And this cost is calculated quite naively, so it's based on the numerical value within the tile that was moved. And then if we do the DFS, I'll do that on easy as well since it's the fastest. So DFS obviously takes a lot longer and a lot more moves to essentially do the same thing. And this makes sense because DFS is more likely to go into cycles and take routes that aren't necessary than breadth first search. So my actual search algorithm code, so these are just a bunch of sort of attributes to keep track of in the different algorithms. So for breadth first search, firstly, obviously we set the goal state to compare the current board to. In order to do state checking to make sure I don't have duplicates, I am using a hash set because, I mean, first of all, it's efficient, but also because it doesn't allow duplicates to be put in. So I'll get into how I implemented that to work the way I wanted it to. And then I have a DQ for representing the queue of nodes that are going to be searched by the algorithm. So for to start, I would just add the root to the queue, which is being passed up here from the run or the main method. It's being passed here. So that's the starting state. We just add that to the queue and then enter a while loop that will continue going until the queue is empty. So until every node in the queue has been searched, or, you know, hopefully until we find our solution. So first we remove the first element because this is breadth first search. So later it will show that when you have a new board, you add it last. And then when you start searching through your queue, you start first because it's first in, first out. And then I'm keeping track of how many nodes have been popped. And every time I get here, I will, to this point, I will add the current state to the hash set to keep track of if we've seen it already or not. And then this is just keeping track of the maximum queue size. So here, if B equals goal, this just means that if we found our solution, then print the solution and return it. And then here, we're basically testing all the different possible moves. So first, it's checking if the blank can move in that direction. And if it can, it creates a new board from the current one. So the current one becomes the parent of the new board. And then it generates a new board with that movement taken. So if it can move left, it makes a new board with the same state except for the blank moving left. And then you just check and make sure that this state hasn't already been seen. And if it hasn't, then you add it to the queue at the end, like I said, because BFS has a FIFO queue structure. And yeah, that's repeated for all the different orthogonal directions. And then